Hello again, physics friends. Today we are going to look at a kind of popular apparent paradox in relativity. There are many different versions of this, but I'll tell the story as a relativistic snake slicer. So imagine we have a zookeeper who's trying to raise money by having a show in which he has a snake move at high speed through a series of chopping knives. And he's going to arrange the knives in such a way where the audience thinks that the snake will get cut, but in fact, in his point of view, he will arrange the situation so that the snake does not get cut, at least according to his analysis. We'll see if the snake agrees. So here's the configuration. We see our friend the snake in green down here, and near him we have a knife that we can pivot and chop. Chop, 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 like that. Okay. And there's not just one of these, actually. We're going to have a few of these knives. Well, two of them. So here's the second knife. And this is how the story goes. The zookeeper says he configures the knives so they're 15 feet apart, and they will chop at exactly the same time. And the zookeeper says, if I'm able to make this snake approach at high speed, this is a 25-foot long snake. If I make this snake approach at high speed, I can get the snake to be shorter and exactly equal to 15 feet, so that when I chop my knives at the same time, the snake will be safe, much to the surprise of the audience. So the argument goes like this in terms of numbers. The knives are 15 feet apart. The snake is 25 feet long, but if he gets the snake going at 4/5 C, then the snake will be length contracted to 15 feet. So here we have the situation with all the numbers, right? So we have a snake whose rest length is 25 feet. We have two slicers at rest in the zookeeper's frame, ready to chop. Those knives are 15 feet apart. And the zookeeper has arranged for the snake to approach at very high speed, 4/5 C, with a corresponding gamma factor of 5/3, such that the length of the snake is only 15 feet. So the snake will come along, and as the knives chop, the snake will fit between the knives just barely, so that the snake is safe and will emerge on the other side in one piece. So the zookeeper tells the audience that this is going to happen. The audience is very excited because they don't know about relativity, and they think, oh my God, we're going to watch this snake get chopped into pieces, and if he does not, it'll appear as magic to them. But the snake, my friends, the snake is worried, because the snake knows a little relativity, and he knows that we should be able to analyze the situation from the snake frame too. And the snake says, it's great that we have this audience here watching me do this trick, but look at it from my perspective. In my frame, I'm 25 feet long. Okay. So even if the knives were at rest, they're going to cut me to pieces. But it's worse than that, because the knives are approaching me at high speed. So they're going to be less than 15 feet apart, and they are definitely going to cut me to pieces. So in the snake frame, we have the following picture here. Snake at rest and knives approaching. And you can see why the snake is worried, right? The snake is 25 feet long. The knives are only 9 feet apart because they're length contracted from their rest length of 15 feet by that factor of gamma 5/3. So they are separated by 9 feet. So you can understand why the snake might be concerned for his well-being. Now, as the snake is pleading his case, Annie G in the audience stands up and says, there is no paradox or contradiction between these two analyses. Okay, I took relativity with James at Wellesley last year. Someone, either the snake or the zookeeper, is forgetting something or is making an incorrect assumption. Because we know, and Annie knows, that we can't have the snake get chopped up in one frame, blood all over the place, and in the other frame, the snake is fine and intact, right? Getting chopped or not getting chopped, that's not a relative concept. Okay, so either the snake gets chopped up or it doesn't. And Annie suggests that she's found a resolution to this apparent paradox, because it's not at all a paradox once you do an analysis correctly in both frames. So what is the resolution to this apparent paradox? Does the snake get cut, or does the snake survive? I'll give you a minute to think about this and see if you can figure out what's going on. All right, folks, hit pause and see what you can do. Did you see where the error lies? Yeah? No? Maybe? Well, lo and behold, the zookeeper analysis is correct. The snake frame analysis is partially right, but the snake has not told you the whole story. It's true that his length will be 25 feet, and it's true that the cutters or the knives are only going to be 9 feet apart in the snake frame. So this looks like there's going to be a problem. But just like the pole in the barn paradox, the snake is going to be fine because these two knives do not chop at the same time in the snake frame. Remember, we were told that the knives chop simultaneously, that the zookeeper is going to chop them simultaneously. Well, that means that in the ground frame, in the zookeeper's frame, both of these blades come down at the same time. But if both of those blades come down at the same time in that frame, they will not come down at the same time in the snake frame, because those two knives are moving and the rear knife will chop first. So let's quantify this a little bit and work through the math, and we'll see exactly how this snake is going to survive even when we do the analysis in the snake frame. Now, going ahead, I'm going to introduce a new symbol for the knife. Instead of drawing the knife like a cleaver like I've been drawing so far, I'm just going to represent it by a long point. So a long stick with a point on the end. And when that comes down, that's like my knife chopping. And on top of that, I'm going to put a clock. Okay, so I'm going to have two of these clock knives, and the clock knives, they can chop by going down and then rapidly up. Okay, and we'll put the clock on top so that we can keep track of the time in each of these images when the knives are chopping and so on. So here we have the situation drawn in a slightly different way. We have the snake approaching 4/5 C. We have our knives that have not yet chopped, they're above the ground. And in the snake frame, we have the snake at rest, 25 feet long, and we have the knives approaching at high speed, and they are, as we know, only 9 feet apart. Okay. So there seems to be a problem. Well, let's see what happens when the knives slice, and we'll start by looking in the zookeeper or the ground frame. So here we have the knives are slicing. We know they're slicing because their clock is reading 0, and their clock is reading 0 simultaneously in the ground frame because we have two clocks at rest, so their readings are synchronized. Okay, but let's look at this in the snake frame, right? If we know that a knife will slice when its clock reads 0, then rear clock ahead tells us that the rear clock is going to slice first because it's going to get to 0 before the front clock does. So we see the snake's at rest. The rear clock is set ahead. It reaches noon first. What, in fact, is the reading on this clock? Let's just work that out. So we can see the RCA is L naught V over C squared, L naught being the rest separation between the clocks, and V being the clock's velocity, or speed in this case actually, 4/5 C. So we have 15 feet times 4/5 C over C squared, which gives us 12 nanoseconds. So we know that the front clock is lower in reading than the rear clock by 12 nanoseconds. So it has not yet chopped. That front clock has not yet chopped, but the rear one is chopping right now. So what we know, though, is that when the left-hand clock chops, it reads 0, and it's chopping at the location of the tail. So what that must mean is the following. We'll move this calculation out of the way, but keep it visible in case we want it later. And then we'll see what the diagram looks like sometime later. Here now we have the left clock is in the act of chopping, and the right clock has already chopped. In fact, it's going to read 12 nanoseconds larger than the left clock, as we calculated before for the RCA. So we know that 12 nanoseconds has ticked off on a moving clock. And we can use time dilation, delta t at rest is delta t moving times gamma, to find that 20 nanoseconds have ticked off in the snake frame. So we could draw that by attaching to the snake a watch or a clock that moves with the snake, or in this case, in the snake frame, it's at rest, and that clock reads 20 in the second diagram. We'd like to now show that, in fact, this left-hand clock is at the tail when it chops. Okay, and so how do we do that? Well, we know that that left-hand clock started 9 feet away from the head of the snake, and in order to make it to the tail, it has to travel 25 minus 9, or 16 feet, in order to get to the tail. Okay, so this separation is the distance it has to travel, and that's 25 minus 9 feet, or 16 feet. Okay, that clock is traveling at 4/5 c, and it does so for an elapsed time of 20 nanoseconds. So we know that distance traveled equals speed times elapsed time. In this case, a speed of 4/5 feet per nanosecond, traveling for 20 nanoseconds of elapsed time, is equal to 5 under 20 is 4, 4 times 4 is 16, 16 feet, which is exactly how far it has to go to get to the tail. So in fact, we've verified that the left clock and the left knife is going to chop right at the tail of the snake, just as it did in the knife frame. And so whether you do your analysis in the zookeeper / knight frame or in the snake frame, you find that the snake is safe for different reasons, or there's a different explanation for it. In the zookeeper frame, the snake is safe because the two knives come down at the same time, 15 feet apart, but the 25-foot snake is actually contracted to 15 feet, so it fits. In the snake frame, the knives are only 9 feet apart, the snake is 25 feet long, but the order of slicing is not simultaneous. First, the right-hand knife comes down while the left one is still up and traveling, and then 20 nanoseconds later, that left-hand knife slices, and it happens to slice right when it's at the tail of the snake. So in both frames, the snake survives, and this has been one of the more popular apparent paradoxes in relativity, in which if you account for some but not all of the relativistic effects, you seem to have a contradiction. And so in the snake frame, we need to account for rear clock ahead in addition to length contraction, and that resolves the conflict. All right, well, this has been fun. I hope you guys have enjoyed it, and be well until next time. All the best.